Hello and welcome to my channel. I am Augustine. Please, if you are new here, kindly subscribe to my channel. And if you have been watching my videos and if you're not yet subscribed, please kindly subscribe fast to the mathematics community. In this lecture, we are going to prove using the principle of mathematical induction. So join me as we go through it step by step. Now, the question is, using the principle of mathematical induction, prove that for all n subset of natural numbers, 1 plus 2 plus 3 plus up to plus n equal to n times into bracket n plus 1 divided by 2. So, to do this, we let the given statement be Pn and then find P1. That's the base step. So we put n equal to 1. That will give us 1 times 2 divided by 2. That is 1. So here the base is 2. Then we go to the inductive hypothesis step. That is where we assume that pk is true for some positive integer k. So we take pk, and that we sum from 1 plus 2 up to plus k. So you have 1 plus 2 plus 3 plus k. And that will give us k times k plus 1 divided by 2. Now, we have to prove that pk plus 1 is true whenever pk is true. So we take pk plus 1, which is equal to summing from 1 up to k plus 1. So we take 1 plus 2 plus 3 plus k plus 1. Wow. And what do we see? You see that what we have here represents what we have here, that is pk, which is equal to k times k plus 1 divided by 2. Then we add plus k plus 1 to it. That gives us pk plus 1. So here we have 2 here. So we can divide this by 2 and multiply it by 2 so that we can have the same denominator. So we have this one to be k times k plus 1 plus 2 times k plus 1 all divided by 2. And we have k plus 1 to be common. So we have k plus 1 times k plus 2 all divided by 2. Wow. So what do we do? We are almost done. So we have our pk plus 1 to be equal to n. So here we have k plus 1 times k plus 1 plus 1. All divided by 2. So now let's see. When you put n equal to k, you have n, we have k representing the n. So once you put n equal to k plus 1, so here k plus 1 is now representing n, and this k plus 1 is now representing n. So we've shown that whenever pk is true, pk plus 1 is true, or we say that pk plus 1 is true whenever pk is true. So by the principle of mathematical induction, the statement Pn is true for all natural numbers. Thank you for watching. Please kindly like, share, subscribe to my channel and leave your comments. Bye bye.